So waves are traveling disturbance, and that can transfer energy, but not matter. Okay. So waves are basically the energy carriers. Waves are of two types. They are longitudinal waves and transverse waves. The second classification is waves are electromagnetic and mechanical. Okay. The first classification is according to the wave motion, and the second classification is according to the medium of medium. It will be stored in the Y. Inshallah. Google Meet में इसमें there is some bug in this one. Good notes. All right. Okay. So now the transverse waves are those waves
Okay. Yes.
I'm rejoining. I'm there. So waves are basically of two types, okay? One is the transverse wave and the other one is longitudinal wave. Transverse wave, you can take the no, it's true. Is it? Yes, it's there. All right. So this is basically an example of a transverse wave. Okay. If you see the wave is trying to move forward and the particles moving like this. So we can say that the motion of the particles and the direction of the wave they are perpendicular to each other. Okay. So wave motion
सर ये सिर्फ longitudinal waves में apply किया जाता है या दोनों longitudinal और transverse waves?
this is transverse wave only, in which the wave motion is perpendicular to the wave movement of the particles. You can call that to be wave propagation. Okay. So if someone asks you what are transverse waves, so you'll say the wave is moving forward and the particle is moving up and down. So they are perpendicular to each other. So wave motion is perpendicular to the wave propagation. Is it clear?
जी.
Example is water wave, and you can take another example to be light waves. Okay. The other thing is the longitudinal wave. Let's take an example of a spring. So what is happening? The particles are moving like this. Okay. Backward, forward. And the wave is also traveling like this. So that means wave motion is parallel to movement of particles. And you can call movement of particles to be the wave propagation. An example is sound waves. Okay. Or like when the spring is moving on. So this one is a transverse wave, and the other one is a longitudinal wave. All right.
Sir, what does wave propagation mean?
Wave propagation means that how the wave is being propagated, like how the particles are moving in a wave. And wave motion is in which direction the wave is moving. Just think about the spring. The spring is moving forward and backward, and the particles are also moving forward and backward. So that means the motion of the particles is along the motion of the wave. But in a transverse wave, the particles are moving up and down, but the wave is moving forward. So they're at 90 degrees to each other. Is this clear or not?
Yes, sir, clear.
Okay, great. Okay, once done, you can screenshot this, and I'm just moving on to the next topic. So now we must know about the important parts of a wave. Can I move on?
Yes.
Yes, sir.
The top parts of the wave are called crest. These are called crest. And this is called trough. Okay. Then this is another crest and this is another trough. Okay. This can be considered to be the height of the wave from here to here. Okay. Now we have a few definitions to be memorized. Wavelength. And then we have frequency. And then we have time period. And then we have amplitude. Wavelength is basically the distance between two consecutive crest or trough. Okay. All right. It's going to be measured in meters, nanometers, millimeters, micrometers, whatever. Frequency is okay. What frequency is? Like how many waves are completed in 1 second? What do I mean by that? Like if this is a wave, okay, this is if I'm starting from here, so this is a complete wavelength. Okay, if I'm starting from here, then this is a complete wave. So in 1 second, how many such waves travel through a one point? For example, I have chosen these 2 points. So I need to check how many waves are traveling over here. So this is the frequency. All right. Frequency means how many wave cycles, how many complete oscillations, how many complete vibrations are being made in 1 second. The unit for frequency is hertz. Symbol is H and Z. Then we have got time period. Time period is basically the reciprocal of frequency. How much time it is taking for a wave to complete one cycle. Frequency is how many cycles in a second, and time period is how much time for one complete cycle. So basically, time period is 1 divided by f. Okay. So if you are being given frequency, you can easily find the time period by making it reciprocal. Is that clear?
Yes.
Amplitude is the height of the wave. So amplitude is the maximum distance covered by the wave away from the mean position. Okay, so this is the maximum height covered. So this height can be called as amplitude. Okay, wavelength is the symbol for wavelength is lambda. Lambda. Okay, so this is 1 lambda. Or this can be classified as 1 lambda. It's not always between crest and trough and trough. Just look at this. If I make this point move over here, then that point will move over here as well. Then this is going to be the wavelength. Are you guys clear with this?
Yes.
Yes, sir.
So it's not always the crest and the crest and the trough and the trough. It can be any two consecutive points. Okay. For instance, I make this point move over here, the white one. So this point also moves over here. Now this is the wavelength. Okay. So you guys must know that the wavelength is basically the distance between 2 points which are at the same position and show the similar properties. Okay. So in like they're called in phase points. In phase. In phase you're going to study in your A levels inshallah in detail. For the time being, you can just so wavelength is the distance between any 2 points in phase. Assalamu alaikum Abdur Rahim. Were you thinking it's a holiday today?
वालेकुम सलाम। नहीं सर, असल में मैं ट्रैवल कर रहा हूँ तो इसीलिए मतलब मतलब अभी मेरे रात के 4 बज रहे हैं।
Oh my goodness. Let me guess, you are. Oh my god. Oh my god. रात के 4 बजे, that means you're somewhere in either you're
सर
Ca-
मैं यूएस में हूँ अभी।
Canada or US. Okay, yeah, I can imagine. Oh, mashallah. Mashallah. Okay, that's too good. Hats off. Hats off. Yeah, let's have some. Yeah, exactly. Exactly. Mashallah. All right. Recording is there. You can access it. Okay. You have not missed so many things. We are just done with this. We discussed about the wave, the types of waves. Okay. And like what are the different types of waves we just covered, and we've just went into the basic terminologies. What is a wavelength? What's frequency, time period, amplitude? Okay. So wavelength is basically the distance between any 2 points in a wave. Time period, frequency is how many waves cycles have been completed. Time period is like how much time it requires for one complete wavelength, and amplitude is the peak of the wave. You can say the height of the wave. Okay. So this is the stuff. So now we're going to move on to two properties of wave, and there is we are talking basically about sound waves. If we see sound waves somewhere, so like this, okay, one is like this, and the other one is like this. Okay, one more example is okay. So you can see here, this is A and B. They are to be classified together, and this is C and D. For C and D, the difference is in their heights, in their peaks, isn't it?
जी
Yes, sir.
And the wavelengths are always almost equal. Okay, wavelengths are almost equal. Okay, so if we have a graph like this, if the waves are formed like this, so this is going to be loud sound, and that's going to be a soft sound. Okay, so that means loudness depends upon amplitude. Are you getting?
जी
A louder sound means like a more
Yeah, can you hear the clap I'm making? Okay, and this one.
ठंड बढ़ती जा रही
So
है।
okay, so if you're striking if you're striking something hardly, okay, that means the amplitude of the wave will be bigger and the sound is going to be louder. Okay, for example, number 1 and 2, you can see that the waves have different wavelengths, although their heights are same, but they have different wavelengths. Okay, these waves are shorter and these waves are longer wavelengths. Okay, so this is basically a high pitched sound. If you guys have heard the chipmunks, can anyone imitate?
Sir, Umar Khan.
Omar can. Why is he like he can't exactly, he can't even, if he tries to, he can't come close to that.
Sir, then how about Saad?
Sad. And Omar, you give a try to this low pitch. Sir, आप कैसे? Now we have got a very low pitch student in our class. Guess who is there?
Sir, it's either Abdul Rahim or either Saad. Sir, these are the only two low pitch students
It's
I know.
Ziad. It's Ziad. Ziad is
Yes, sir,
having a
he's
very
he's very low pitched.
yeah, exactly. So high pitch is where the waves are closer to each other. Okay, a low pitch sound is in which the wavelengths are farther and frequency is lesser. Okay, are you guys getting or not? This is having a
Yes, sir.
greater wavelength and a lower frequency, and a high frequency is lower wavelength, and that means it's a high pitch sound. I hope it's clear to all of you.
Yes, sir.
Perfect. Okay, so we are done till here. Okay. In the exam, a very, very important question is that How we can find? Okay, now the speed of sound. Wave is the equation for the speed of a wave. The speed of wave is v equals to f times lambda. Okay, where f is the wave speed and f is the frequency and lambda is the wavelength. I hope Ziad is there in the class. Yes, he is. Okay. Ziad, I would request you to tell the class about the method we are going to follow to find the speed of sound in air.
Speed of sound in air, like the experiment.
Yeah, the experiment. How we can find out? Like if it is a 4-mark question in your exam, in your paper 4, how are you going to express it? Okay. So tell your fellow students how we are going to write it down.
Okay, so you need to be two people in a room. First, you take the measurement of the room from one side to another. Then you take a source of sound and a timer. When both students will stand on one end of the room, and then one student will use the source of sound. Say he claps his hands. Okay. Then the other student will measure the amount of time it took for him to hear the echo. He will then divide that time by 2 and then do equation 1 over. Then he will find the frequency. No. Then he will use the distance of the time to find the speed.
Yes, very good. Excellent. Nice. Okay. So Ziad told us that two students are going to stand in a room on the same side. One is going to clap, the other one will be having a stopwatch. Okay. As soon as the clap, as soon as the echo is heard, the student is going to like as soon as the student claps, okay, because he's standing near to him. So he's going to start the timer. And as soon as he hears the echo, he's going to stop the timer. So he's going to measure the time. Distance is already known, how much distance is covering. Because it's an echo, so sound is going and coming back. So you're going to divide the time by 2 or you divide the distance by 2, okay? And you can use the formula speed equals to distance over time to measure the speed of sound. Perfect. There is another method and that is called the flash gun method. I'll explain you that thing as well. How are we going to do that? So, yeah, what is wrong with this, by the way?
सर मुझे एक
Good.
सवाल है
हाँ पूछो.
आपने
Yes.
ए में लिखा था इंक्रीज इन फ्रीक्वेंसी एंड डिक्रीज इन वेवलेंथ और बी में आपने जैसे ये वेवलेंथ और फ्रीक्वेंसी जैसे इंक्रीज डिक्रीज जो है ना आपने बताया आपने सी और डी में नहीं बताया मतलब क्या दोनों वो सेम है
No,
Like-
they're not. C and D are something else, and that one are something else. They're okay. So they're not correlated. A and B are linked
Sure.
with. Oh, okay. And बेटा इतना glitch हो रहा है वो टाइम आ ही गया है वादा पूरा करने वाला.
सर मैं आप हुक्म करें आप ये बताएं कब आना है मैं कोशिश करूंगा बस अम्मी वो अलाउ कर दें
Ayahan has promised for an iPad 2024 to sir. I'm just waiting for Ayahan to come.
सर
Okay.
एक महीना और रुक जाए ना ये 2025 की अनाउंसमेंट हो जाएगी सीधा वही ले आता हूं
Okay. Nice. Yeah, where is that? The worst thing about GoodNotes is that we cannot sort out our files. It just gets missed out. Anyways, the recording is there. You guys can look over there. Okay. So now there is another method, and which is called the clap method or the flash gun method. And whatever like you guys like more, you can do it. So one of the student is going to stand up over here, and the other student at an appropriate distance with a stopwatch. Okay. So what is going to happen? It's a flashlight going to be fired. Okay. Light is going to be seen. Okay. Light is going to be seen. As soon as the light is seen, the student starts the timer. Okay. And as soon as he hears the sound, he's going to stop the timer. The distance between them is already known to us. So we are going to use the formula speed equals to distance over time, and you can find the speed of sound. The speed of sound in air is, okay, what are the speed of sound? Speed of sound, you are being asked to write down the estimation. Speed of sound in air is approximately 340 or 330 meter per second. Okay. Nextly, speed of sound in water is around 1500 meters per second, and in metal, which is solid, it's almost 3000 meters per second. Okay. So speed of sound is highest in solids because there is no interruption, there is no hindrance to the sound molecules to travel. All right. So have note of this. This has been asked in the exam so many times. I hope all of you are now able to write down the investigation thing if it comes for 4 marks.
जी सर.
All right, perfect. Ayan, you came a bit late. We did a question before you came to the class. Okay, I'll request students to make you do that question. Okay, and that was an important one.
Okay, sir.
Okay. Once we are done with this, then we are going to see and observe some of the phenomena the waves are doing. Okay. There are 3 different phenomena the waves exhibit. One is reflection, one is refraction, one is diffraction. Okay. For sound waves, reflection is called echo. Okay. We are going to observe reflection, refraction, and diffraction for water waves. Okay. And you will be asked to draw the diagrams for them. And that is one of the most complex part of the syllabus because it requires some skill. Okay. I might make a short video for you guys how you're going to do that because I need to have a piece of paper and need to do how you're going to do that using measurements. Okay. So inshallah, I'll try to make a video on that. Okay. Or either we can do it in a class with practice, all you guys having your, I'll give you the printouts. Okay. You can take the printouts and then do because it requires measurements sometimes. All right. So water waves, they reflect, they refract, and they diffract. Reflection is going and coming back into the same medium. Refraction is when waves enter from one medium to another. So they bend, they change their direction. And diffraction is you bring some obstacle. Okay, some small obstacle, and the wave just passes the obstacle. So you can see some curvatures, okay, or you can see some bending, or you can see some spreading out of the waves. Okay, so diffraction is basically spreading out of the water waves or any waves after they pass from an obstacle. For light waves, we are just going to study about refraction and refraction. No diffraction, it's an AS in your A levels. Okay, so for the time being, you guys can take a break of 10 minutes. Okay, you can rejoin. So inshallah ta'ala, we are going to solve some problems related to V equals to F lambda from the past papers. Okay, see you guys after 10 minutes, inshallah. Okay, meanwhile, you can recall, revise.
Okay,
Just go asr ki namaz padhni hai, asr ki namaz padh le. Okay, see you then. Okay.